This series doesn't look like a telescoping series until you actually do the partial fraction expansion. So let's try that, partial fraction expansion. And to do that, you need to factor n cubed minus n, which readily is factored by n squared minus 1. And this can be further factored as n plus 1 times n minus 1. So let's write it as a over n, and then b over n plus 1 plus c over n minus 1, because these are the factors, right? Now you multiply this to the other side. And remember, because this denominator is this thing, when you multiply this to this one cancels. When you multiply this one with this n and n cancels, then what do you have left? A times what? Yeah, n plus 1 times n minus 1 after canceling the n, right? And then when this gets multiplied to this one, what do you get? Plus b times?
n minus 1.
Yeah, n minus 1 plus, and likewise c, n plus 1. Now what we need is these two sides have to equal as functions of n, right? Therefore, this one is an identity between functions of n. That means whatever number you plug in for n, both sides should give you the same answer. So we can freely plug in something and say the two sides are equal. Okay. What should I plug in? N equals 2? 1. Because then 1 minus 1 is 0, 1 minus 1 is 0, and you just get 2c on the right side, whereas you get 2 on the left side, which gives you c equals to 1. Good. What else should I plug in?
Negative 1.
Negative 1, because then n plus 1, negative 1 plus 1 will be 0. So this will be 0, this will be 0. The only survivor will be this one. So you have 2 equals to b times negative 1 times negative 2, so that b is again equal to 1. Right? Negative 1 times negative 2 is 2. Divide 2 both sides. And what else?
0.
N equals to 0, because then these are 0. When 0 is multiplied 0, the only thing that survives is this one. 1 times negative 1 is negative 1, so you have 2 equals to negative 1 times a, so that a is equal to negative 2. Okay? Alright, so let's see what that means. That means this identity says you have 2 over n cubed minus n equals to negative 2 over n plus 1 over n plus 1 plus c 1 over n minus 1. Now, it's a bit tricky if you start plugging in n equals to 2 and upwards to this side, because it's not in order. So let's reorder this so that the denominators are in increasing order. That way it's easier to see the pattern. So let's rewrite it as 1 over n minus 1 minus 2 over n plus 1 over n plus 1. Then we can start figuring out what's going on by writing this explicitly. So that means this is now equal to sum of 1 over n minus 1 minus 2 over n plus 1 over n plus 1, so that when you plug in 2, let's see what you get. 1 over 1 minus 2 over 2 plus 1 over 3. And you don't want to say 1 here, because you really want to see the pattern. Okay, okay, so what's the next term?
N equals 3.
Yeah, so n is 3, then what do you get? 1 over 2 minus 2 over 3 plus 1 over 4, right? Okay? And then so on and so on. Well, let's do a few more terms because we still don't see how the cancellation is working out. So the next one will be 1 over 3 minus 2 over 4 plus 1 over 5. The next one will be 1 over 4 minus 2 over 5 plus 1 over 6, and so on and so on. Okay, so what's canceling? It's not so easy to see, but it does cancel. What's the canceling pattern here?
1/4, 1/4.
So you see
1/4 right there.
1/4, negative 2/4, and 1/4, right? That's like 1 minus 2 plus 1. What's that? 0. So these just cancel away. Right? What else?
The negative 2/3 cancel, or doesn't cancel.
Right,
all
right.
the
This
way.
1/3, negative 2/3, 1/3, they cancel. Now, would you believe me if you said that's always going to happen
Yes.
with something that's next, right? So everything here will cancel, and the end result will be what?
It'll be
1 minus 1 plus 1/2. These are the only survivors, right? So the answer will be 1/2. Okay, but not yet, not yet. This is like the intuitive way of saying it, but remember, sometimes we get tricked into thinking that that's the answer, but we had an example last time where if you cancel like that, you get a finite number that didn't make sense. So let's do it right. Okay, so what we really need to do is to be able to say that this thing here is a limit of capital N going to infinity of capital N from 2 to capital N, where you have 1 over n minus 1 plus, actually, minus 2 over n, and then plus 1 over n plus 1, right? And then this one will be, when you, the beginnings are the same, right? 1 over 1 minus 2 over 2 plus 1/3, plus 1 over 2 minus 2 over 3 plus 1/4, plus 1/3 minus 2 over 4 plus 1/5, Okay, so tell me, what's the last term you get in this, before you take the limit, sorry. Before you take the limit, capital N going to infinity, what's the last term you get? When n is capital N is plugged in, right? What would you get if you do that? Capital N is plugged in where?
It would be
For the small n, right? So what do you get?
1 over n minus 1
Yeah.
minus 2 over capital N plus 1 over big N.
Right. What will be 1 before that?
1 over n minus 1 minus 1.
Actually, yeah, so it will be minus 2.
2
These will be 1 less, right? Just like that. Right? And now let's see how the pattern works. The pattern works so that these survive. Everything else will cancel, right? This will cancel. So everything survives, and then you see that this one plus this one will give you something, and these will be not completely canceled, but this one will cancel, right? And this one will cancel with something else. You see that? So the pattern is that after you cancel everything, you end up with limit capital N going to infinity of, this is 0, this is 1/2, so you have 1/2. 1 over n minus 2 over n is minus 1 over n, plus 1 over n plus 1. And this is the limit that you have to calculate. And this limit, as capital N goes to infinity, these are both 0. So you end up with just 1/2. So that's like the proper way to do this, rather than doing it intuitively, because we had this example where, in the second example we did right before this, we had these terms that did not go to 0, and you ended up with infinity rather than 0, right? So sometimes that can happen, so you have to be careful. So that's the answer.